Okay, so order operations here with the prep is going to be case bushing, then seal, then parking pole housing and roll pin, and then we'll install our selector shaft seal here, and then we will install the rooster comb parking rod, selector shaft assembly, and install those roll pins. Once all that's done, at that point we can go ahead and install the output shaft, so ring gear assembly, then plan it, and then so on and so forth. Alright, and to knock out the bushing, you're going to need a driver that allows, for purchase on the bushing, but does not kind of, overlap the case itself. So I use a different driver to install the new bushing compared to what I use to remove the existing bushing. Alright, just double check your board, make sure there's nothing weird going on. Alright, so for your case bushing, this is a Durabond, and this is a parted bushing, if you will, so it's got an open end. So I'm going to put that 180 out from the notch here in the case. And then, I apologize, I actually had the wrong bushing driver on the bench for some reason. It's this bushing driver here, and it's even labeled. It's been a long day, so I know no excuses, but that's my story and I'm sticking to it, so to speak. Alright, so again, firm smacks, double check, make sure you're square. Yeah, it's kind of one of those measure twice, cut once type of deals. Okay, just check it all the way around. Wipe away any kind of, miscellaneous whatever that might have got up in there. And before you install your seal, it's strongly recommended you check this. So let me move the camera so that we can lower the ring gear basket output shaft assembly carefully into position, just to make sure that this bushing is square, because if it's not, then the journal there will bind up on it. And I'm going to just put assembly lube to protect it. Alright, let me move the camera, and then we'll resume with the ring gear basket test fitting the bushing. Okay, first install your bearing. Okay, this side here, the inner portion of the bearing faces you, and this outer portion faces the case. And next, carefully grab up your rear gear set assembly, carefully lower it into the case. And see to it that it settles all the way in. Then just go ahead and spin it. Make sure it spins nice and free in both directions. Okay, appears to. So if you wanted to wait to install the seal, you can leave this assembly in the case now. So if you want to leave the gear set in, you can do that and simply install the seal later. And that could be done in, whenever you want, as long as, if you make the case vertical, nothing will fall out, or if you make it horizontal, nothing will fall out. Alright, so this threaded rod is M12 175. You can get these at any hardware store, and 18 to 24 inches in length is ideal. I think this is 18 inches. And then just a couple of large fender washers. I have a spacer in here and a lock nut. And basically, I have a lifting tool that cost me less than $10 to put together. All right, so that's out of the way. We'll retrieve our bearing, and then I'm gonna spin the case back so that it's inverted, and we'll install that rear seal. Okay, make sure you have an adequate seal driving tool. So, I'm just gonna use this big giant driver that my fabricator made for me. So just make sure the seal itself is square in the bore. And then smack it home. That's it. Use a ton of assembly lube. Okay, we have all our elements here for parking linkage and gear selection. So parking pole housing, the 2 O-rings and its corresponding roll pin, selector shaft seal and its roll pin, and rooster comb and its roll pin. And then lastly we have dipstick tube and or dipstick plug. I'm actually going to install the plug and then send this on. I actually don't know if he has a tube or not, so we're going to basically send him both. But I'm going to install the plug because it'll protect the inside of the transmission from anything getting in there in transit. So this is the parking rod assembly. Part number is 242-80048. And this is for the 6L80s. The 6L90 has an equivalent, but it is a little bit longer owing to the fact that the 6L90s are longer than the 6L80s. So obviously don't mix and match. All right, we'll go ahead and install those O-rings. I want to do the housing first for the parking pole. Then we'll go ahead and install our selector shaft seal, shaft, roll pin, along with the rooster comb assembly to the parking rod. And then that will be it insofar as linkage is concerned. Then we can start putting all of this stuff back into the case. Okay, installation of the parking pole housing is very straightforward. So you're going to have your roll pin location here. And then you have the corresponding slot here. So all you're going to do is just line up the slot on the housing with the hole for the retaining pin. Put a generous amount of assembly lube here on the O-rings and in the bore, and then just simply install it. Now, what you'll need to do is, once you have it started, you're going to need to take a finger and you're going to need to hold the pole itself inboard so that it then comes to rest here in the large cutout for it. And when you install these O-rings, make sure you install them from the back side of the housing, not the front. Otherwise you risk getting it caught up on some of these edges here in the big cutout for the pole, and that may break it. Alright, let's go ahead and hold in our roll pin, or excuse me, our parking pole. Yes, hold in our roll pin. Hold in that roll pin. Don't let it come loose on you. Okay, so once it's in, just eyeball the housing in relation to the slot. Okay, make sure it's good. And then you may notice one side is a little bit more tapered on the pin than the other. So the more tapered side or the more conical side should go inboard. And then you're going to use a 3/16 roll pin punch. Okay, there's going to be a little bit of wiggle room in the housing. That's perfectly normal. And just tap it until it bottoms out, and that's basically it. Alright, now I'm going to reposition the camera so we can install the selector shaft seal, shaft, rooster comb, and parking rod assembly. Okay, here's your selector seal. This is the inboard facing side. This is the side that faces out. Just get it as square in the bore as you can. Make sure it stays put. And then go ahead and get in behind it. And then a few smart taps. Alright, now go ahead and lube up your selector shaft. If you want, you can put a little bit of assembly lube on the seal itself. And when you install this initially, only install it part way, because you got to leave some room for your parking rod and rooster comb. Okay, so about there is fine. Alright, now go ahead and grab your rooster comb and parking rod assembly. You want to position it like so, and you have your manual valve engagement stud inboard. So seat the rod in the housing and move the pull aside so that you can get it fully inside the housing there, and then just simply install it. And you're going to probably need to tap the selector shaft until it's all the way seated. Okay, there you go. So now what you need to do is line up your roll pin holes in your rooster comb and on your selector shaft so you can seat the roll pin. And the roll pin's right here. So before we do that, I want to actually seat the roll pin here so I know good and solid, and then at that point the last roll pin will be the rooster comb 2 shaft. So if you seat the selector shaft a little bit too far like I did, you may have to tap it out just a little bit. So now I have the roll pin slot fully exposed. So this is the smallest of the 3 roll pins, and you're going to use a 1/8 roll pin punch. Okay, tap it in until it's seated all the way, and then check it. It's not going to come out. So to remove all of these roll pins, you need a special collet style puller. Well, this one you can remove with a regular hammer and roll pin punch, but these two, you need that special Kent Moore tool. I'll flash it across the screen. It's available from time to time on eBay, and you can buy it there. I will say that the weight for it, the slide hammer element, is not as weighty as I would like. Alright, just make sure you have access, and if you want, you can make sure that this is engaging and disengaging the rod. And the rod engaging the pull before you hammer the roll pin home. So if there is one end that's a little bit more conical than the other, that's the end you want to put inboard. Again, just double check, make sure you got everything lined up as it should be. And then just drive it home. So I'm checking, I want it to be symmetrical, you know, an equal amount of the pin exposed on either side. A little bit more to go. Okay. Alright, so with everything now engaged as it should be, we're ready to assemble this case for the final time. I'm going to leave the pump perimeter O-ring off because I need to measure end play so that we can then dial it in using that shim kit from Superior Technologies. But other than that, everything's going into this case. Alright, go ahead and start with your rear case bearing. You may need to refresh the assembly lube on the bushing and the seal. So we'll do that as well. And then grab your rear gear set, have your lifting tool positioned, installed, and then carefully lower everything into the case. Alright, make sure it's home. Okay. You notice I was rocking it side to side just a little bit. That will help you get it, you know, into the bushing so that it will ultimately slide past and to the seal and ultimately on the bearing surface. All right, so this is M12-175. The rod itself is roughly 18 inches long, and then as you see I have like a spacer, a couple of washers, a couple of nuts, and this large fender washer, and it's, I don't know, $8 to $10 worth of materials there. Adapt case makes the tool, like I said. If you want, you can spend the money on it, but it is kind of expensive. Alright, now what I like to do is lube up the area here where the center support's gonna ultimately slide into, and then lube the center support itself. So we've installed 2 case bearings, or bearings that go into the case. We've got to install 1 more before we install the center support. And that is our rear gear set thrust bearing to the center support. It's got a locating flange. That flange faces down and locates on the front sun gear in the rear planetary carrier assembly. Alright, those planetary carrier assemblies are known as Ravenel style carriers. That's the design. They allow multiple different ratios in one housing, and that's why they are favorable on, you know, for use in these kinds of transmissions. Alright, center support. So very simple and straightforward. Just align your feed ports to the 6 o'clock position and carefully lower it into the case. Okay, just align that and the lugs. I'm looking at the 9 o'clock lug. That's it. So I'm double checking. Want to make sure I have an equal amount of room all around the center support snap ring groove. Alright, now it's time to grab up on that giant snap ring and shove it into the case. I'm going to use the big pliers, and then from there we will install the hubs. So, not sure if you can see it, but I made a scribe mark right here on the case to indicate where the two ends of the snap ring were. So I'm going to actually reposition the camera so you can see the installation, and I'm going to orient it so that it goes back in that exact same way. I don't know how critical that is. I'm going to be perfectly honest with you. It's not something I really paid a whole lot of attention to, but I wanted to make sure that in the teardown video I mentioned it, and I did that. So if it is critical by chance, all the units I've done, I've never paid attention to it, but if it is critical, I want to make sure that that's in that video as well as this one. Okay, so for the snap ring, it is directional, so you're going to have a flat side here that faces down, and then you have a beveled side which obviously faces up. So here's my scribe mark. Now, I've seen guys on videos of these and similar transmissions, specifically the Ford 6R80, install this snap ring literally by hand. There's a video that Exity has put out, and it's kind of like a nice overview of the whole installation process of every every component into the case. And toward the end of the video he fills the case up, and one of the things he does is literally takes the snap ring and by hand installs it. He scrunches it up like you just saw me do and gets it right up in there without the use of any kind of special tool. So I thought that's pretty impressive, knowing that how beefy these things are, but I'm simply not that strong. And this 6L80 snap ring is beefier than the 6R snap ring. It's it's not hugely different, but it is a little bit thicker and a little bit more stout. So anyway, if you have these giant pliers, they make very quick work of this thing. And I think I'm slightly off from where this thing was when I took it apart, so let's see if I just correct it real quick. Just walk it over. I think I'm good. Okay. Alright, if you want to know where these things came from or who makes them, it's a company called PRTC. They're in Utah, I think Salt Lake, and 801-373-9608. That's their phone number. I don't know if they have a website or not, to be honest. They probably do, but they have a store on eBay, and that's where these came from. Alright, so now we're going to install our two hubs and their associated bearings. So first we have the center support to 3/5R clutch hub bearing, and it has a locating flange, and it just sits right here. Now we have our 3/5R hub, so we'll lube up the bushings. And then I lube up the shaft. Just make it nice and lubricated and settle it on in. And make sure it's fully bottomed out. When you replace the forward-facing bushing in the center support, you gotta take a couple extra seconds to make sure it is absolutely square before you start pressing it in, because if it's just a little off kilter, it'll go in that way. And even with the correct press tool, the one that's specifically designed to install that bushing, it will still go in slightly cockeyed, and when you try to test fit your hub, the journal, it'll bind up. And I actually did that with this transmission. I screwed up the bushing install, and as a result, I had to take it out and install a new bushing. Not pleasant. Okay, next bearing is going to be the 35R to a 1234 hub bearing. Again, has a locating flange, which is going to face down toward the bushing. Okay, so another bit of commentary toward the installation of this bushing in the 35R hub. This bushing with the little oil dimples, if you will, has to be installed to the correct depth. If it interferes with that locating flange, then the bearing will be proud in the hub, and that will result in possibly an interference fit with all the rest of the case components. So again, if you do a lot of these, you're going to have the dedicated bushing driver set for all these bushings. They locate, seat, and install everything pretty much perfectly. The only wrinkle being that center support forward bushing, but if you don't, and this is kind of a DIY build for you, and you don't want to spend whatever it costs for the bushing driver kit, then just purchase your bushing kit and take it to a transmission shop that does these, and they can R&R the bushings for you and install that front pump seal as well. And you'll have de-risked this portion of the build for yourself. Okay, 1234 hub. Alright, lube up your shaft and the inner diameter. You can lube up the splines as well. That's perfectly fine to do. If you didn't do that, that's also not the end of the world. Not a big deal. Okay, make sure it's fully seated. Everything should be spinning nice and easy. And I'm spinning the 35R hub so you can see how it reacts with the 1234 hub, or how the 1234 hub's spinning in the opposite direction. I don't know why I'm doing that. I mean, no particular reason. I just felt like it. Okay, lastly, you have your 1234 hub bearing to your 456 hub. So I like to use the green assembly lube on these rollers. This will help protect them from, any potential damage on initial startup. Just stick it in there. Alright, now go ahead and grab your 456 clutch hub. Have your bearing in place here, and your bearing race located here. And go ahead and carefully lower it in. Alright, this is going to be a little bit difficult to spin simply because you have the entire weight of everything else. In the case, gravity's working against you, but it should still spin. And those three little tabs on that bearing face up. Okay, so now we're going to do something a little bit different. We're not going to pile in the rest of the case components as you would expect, because we need to do an end plane measurement and make adjustments using that Superior Tech shim kit. So what they have you do is they have you take the 456 clutch out of the input drum and then load the input drum, planet, sun gear, the bearings, right over here on the hub. They have you leave out the 35R drum, and then they have you install the pump assembly sans pump O-ring, and that's why I haven't installed it. And I don't think I mentioned it in the pump assembly video, part 1 of this series, but that's why I prefer to keep that pump O-ring out. So that's what we're going to do now, and then once we have the pump installed, I am going to bolt the pump down. Now, the directions for Superior Tech tell you to just put in a couple bolts. I like to put in all the bolts. That's because it gives me just a more realistic depiction of what the case would be like when it's all assembled for the final time, and then I'll take an end play reading, and then from there we'll make adjustments with the shims as we need to dial it in so that we have it exactly the way we want it. Okay, let's revisit the instructions in the shim kit real quick. So basically, they tell you to assemble the transmission up to the 456 clutch hub, which we've done, and then they have you install your front gear set and your bearings and washer on the empty 456 clutch drum. So we have our clutch pack out of the drum, and then essentially what they then have you do is leave out that 3.5R drum. You don't really need it, and then go ahead and install your pump assembly. So these are the instructions that we're going to follow, and what I want to do is I want to do this without any shims whatsoever initially, and then we're going to see where we're at. Okay, so go ahead and take your planet, flip it upside down, install your thrust washer, and then carefully lower your planet into the ring gear basket. You know, be mindful not to come in contact with your sealing rings. If you noticed this drum earlier in the segment, it had its sizing tool on it. I like to keep that sizing tool on there at all times until I'm ready to install everything back into the case. So, because we have to install the pump over this, I obviously can't keep it on there at the moment. Alright, if you haven't done so, heavily lubricate the inner diameter of your stator. Again, leave the pump O-ring off. And lubricate the bushings. More lube in the stator shaft. And then it will come to rest on the splines of the sun gear. And what you may have to do is rotate your drums to get the planetary and sun gear to move so that the splines on the stator can mesh. And that's exactly what's hung up here. Okay, I was a little off kilter, so that's what was going on. Alright, now I'm going to go ahead and install all the bolts. And like I said, I want to have them all in here so that I get more of an accurate representation of where I'm at. Alright, 9 bolts. All take 15mm socket. Alright, these bolts all get 53 foot-pounds, so I'm only going to torque 4 of them. I mean, that should give me what I need to do a measurement. I'm going to use a different torque wrench. The one disadvantage that you have when using an engine stand on wheels like this is that when you go to torque up bolts that do require, you know, a fair amount of torque, the stand will want to move on you. And when you're not filming, that's no big deal. But when you're filming, it can be a problem. As you can see, alright, now we have everything torqued up, so dial indicators in place, set to 0. Let's see what kind of end play we actually have. And I gotta make sure it's fully seated. Looks like 39 to 40 thou. It's been turning until 1 thou below 0, so I'm going to call this 39 thousandths. So I'm going to go ahead and remove the bell and get the 456 drum out of the case, and then we'll show you where to put shims. So given we have 39 thousandths of end play, we need to install some combination of shims to reduce that play to about 6 thousandths. Okay, back to our shim pack. So we have all 3 sets of shims laid out. There's a 7 thou set, 10 thousandths, and 15 thousandths along with our bearing. Alright, so you notice here in the instructions, they just tell you what the orientation is for the bearing, and then what they want you to do is install the shim on this side of the bearing. So you place the bearing onto the hub, and then you install your shims. Of course, this one is wanting to stay on there. So we had 39 thousandths of total end play, and basically the factory will set it between 8 and 33 thousandths, and then just like they mentioned here, if you machine your stator, or stator support rather, then you typically free up an additional 5 to 7 thousandths. Just depends on what you're doing. So, and of course, you know, different units have different tolerances. So what we need to do is tighten this up so we're between 4 and 6 thousandths of an inch, which means we need to lose 33 to 35 thousandths. So if you use one of each, here on the far end, this combination 1.7, 1.10, and 1.15 give you 32. So in our case, if we use 2 10s and a 15, to give us 35, and that would give us what we needed in terms of the 4 to 6 thou range. So 2 10s and a 15 is what I'm going to go with. So we can quickly measure that. And this is giving me 40 thou, so for 15, this is 12 thou. Let's see what this one is. 10 thou. So that's giving us 12 thousandths of an inch. So take a 7. Now let's see what we got. So 35 thousandths. Alright, I'm gonna put them and the bearing back onto the hub. And there they are. So now we're gonna finish assembling the rest of the case. Gotta put the 456 clutch back in the drum, get the that plan and all that stuff. We're gonna put that back in, and our pump. And I'm gonna leave the O-ring off again, just one more time. I wanna double check, because if I'm too tight, if I'm like 1 thou, 2 thou, or have an interference fit, I wanna be able to swap one of those 10 thou shims for another 7 thou shim. Unfortunately, it's not always as simple as just doing the math and you know, coming out exactly as you would calculate in reality. Sometimes you get slightly different readings than you might expect if you're just running the numbers by themselves. So that's why, although it's tedious, I like to double and triple check so that when I put this back together for the final time, there's no uncertainty about it. Okay, there you see the installed shims. So now what we're going to do is put the 456 drum back in. Again, no clutch pack installed. And then our pump without the perimeter O-ring. And then we'll do another measurement to see where we are at. Okay, we have the indicator set up, and now we're going to take another check. So we have the prescribed 4 to 6 thou travel, so this case will be nice and tight when we put it back together. Alright, with the 456 clutch back in, I want to touch on something I didn't mention, at least not in this particular video. I mentioned it in part 1 and possibly part 2. At this point I can't even remember, but it is critically important, so I want to take a few minutes to talk about it here, and that is what you need to do from a tuning perspective if you're running the Sonics 456 kit. So again, if you're not familiar with this kit, I'll kind of just go over, rehash what I covered in previous videos, but this kit allows you to squeeze in an additional friction and steel in this clutch pack. And so it will have you eliminate the wavy plate, and you will install the thicker bottom steel that Sonics gives you. It's basically like a pressure plate, with this being the backing plate. Now, when you delete the wavy or cushion plate in here, you need to turn off the air bleed in the 456 shift tables. If you fail to do that, then you will not have proper function with the compensator feed circuit in the 456, and that could lead to drivability issues. Now, I'm no expert in tuning. In fact, I've never tuned an engine or a transmission in my life, so I'm going by what Circle D and others have told me when it comes to tuning treatment for the 456 when you are doing an aftermarket stack up, or at least installing aftermarket clutch components like the Sonics 456 kit. Alright, go ahead and lube everything up for the final time. You want to hit the inside of your stator nice and generous. Get your sealing rings, get your journals, pretty much get everything. So all clutch packs back in their respective locations, and we are ready to button this thing up for the final time so that we can perform a case air check. Alright, I'm going to reposition the camera so you can see what's going on. We'll load everything into the case for the last time. Okay, make sure all of your shims are in place. Double check the underside of the 456 drum. Sometimes, you know, due to just, you know, a little bit of transmission fluid or whatever, assembly lube, they'll adhere themselves to the underside. So you just want to make sure that all of them are on that bearing. Alright, so we're good. And then carefully lower your completed assembly into place. Okay, make sure everything's moving nice and free. You know, you don't want anything weird, anything wonky. All right, next 3/5R drum. So with the drum, what you want to do is just carefully lower it into the case. And they make special tools that you can use to lift the drum and then manipulate it, but you really don't need them. All right. Just periodically check it. Okay, I think we're in. Now for the pump O-ring. Just go ahead and put it on. I know you can't see me, but I'll show it to you once I have it on. And you can put a little bit of assembly lube on the O-ring as well. Doesn't hurt. Put a little bit of assembly lube on the perimeter of the stator, or I should say stator and stator support. Put lube here. And then lube up your stator shaft if you feel you need to. Okay, fully seated, time for bolts. That camera angle may not have been truly optimal, but if anything important was not in the shot, I apologize. You couldn't see me manipulate the 3/5R drum, but what I was doing is turning it clockwise, then counterclockwise, and it's seated when I turned it clockwise. And that's clockwise going like, you know, I'm sorry, counterclockwise. Counterclockwise. So when I was turning it clockwise, it wasn't seating. When I turned it counterclockwise, the stator splines and sun gear splines meshed. Hey, if you want to do a quick check for binding, just go ahead and attach your vice grips that you were using prior to, pull up on the shaft. Make sure it spins. I mean, these are a little bit too long. I can really only turn them as far as the bell is concerned. So what I'm going to do is I'm actually going to get the case horizontal and spin it that way before I torque the bolts down. I mean, you can help turn the input shaft via turning the 3.5R drum. Just be careful with your fingers. I don't feel anything unusual. Nothing seems to be amiss. Nothing's binding. Nothing's galling. It's a tight case. We only have 6 thou of travel, but it's set up perfect for a performance type application. So now we'll go ahead and torque down all the bolts. And as I made mention of earlier, having the transmission on an engine stand with wheels as opposed to a bench mounted fixture does introduce a little bit of complication when it comes to torquing, because you're going to be working against, the thing's tendency to want to roll. Come here. Okay, 53 foot-pounds. I actually typically use 50. That's fine. It's not going to hurt anything. You're not going to have any problems. The bell is suddenly not going to separate from the rest of the case during operation. So I like to work up the torque. Just get all the bolts tightened to the point where they're ready for that final torquing. And you don't have to do this, just to be clear. It's just something I like to do. So go in a crisscross pattern. Other than that, there's no tightening or torquing sequence like there is with the, pump half bolts. Something feels weird, just stop and remove the bolt, see what's up. All right, case is fully assembled, so one last order of business when it comes to the case itself, and that is our torque converter seal for the input shaft. So I'll go ahead and install your seal, or O-ring rather. Alright, now we'll go ahead and turn the case horizontally so we can perform a case air check, and then from there we'll go ahead and finish this thing up. Alright, now we're ready to perform the case air check, and what we're looking for here is robust apply in all of our clutch circuits, and we're also looking for air to retain trapped in the compensator feed circuit. So we want that circuit to retain air, at least for a split second, while we have the nozzle, hard and fast to it, but when we release the trigger. So that's going to be the test. So we got our 1, 2, 3, 4 feed, R35R, R456, compensator feed, and then I also labeled the boost and the TCC locations. I'm not going to test those. I mean, you can test them if you want, but it's not really necessary. Then we have our 2.6 and our low reverse clutch. About 70-75 psi air is usually sufficient. So I'm going to put a little bit of downward pressure there, and then I'm going to hold the back of the nozzle because air tends to escape from it. Okay, so here's your forward, or 1, 2, 3, 4 clutch, 3.5R clutch. Your 4.56 clutch is inboard inside. You can't really see it from here, obviously. And then it's going to be your 2.6 and your low reverse. Okay, so when you're putting air in the forward clutch, you always put a finger here. Make sure that nothing happened on the way, pump on the way into the case. Make sure there's no air whooshing out of the 3.5R circuit. Okay, I mean, all the air you're hearing is coming out of the back of the nozzle. So 3.5R. Okay, hear all that air trapped in the circuit. That's what you want. 4.56. Two 6. And then low reverse. Now we'll do our compensator feed. So again, we're looking for air staying trapped in the compensator feed circuit. Okay, that's what you want to hear. I know it doesn't sound like much, but if you weren't getting that at all, then I'd be concerned that either the second or the top sealing ring on the turbine shaft may have been shaved a little bit. Alright, so now you're going to take your seal and you're going to install your 2 short springs in the tall outer locations. Alright, now I'm going to take this away for a second because you want to put assembly lube in there to hold these seals in place while you install this. So, whole bunch of green assembly lube. And then just place them into position like you normally would if the springs and the inserts weren't there. So you'll notice there's a little bit of a gap between the very top of this seal before you make contact with the insert. And that gap is going to be filled by the corresponding inserts on the valve body side. And then you have, of course, your valve body seals for the pump. Alright, with that task done, we're now going to go ahead and install the control body complex onto the case. Okay, first things first, I like to have the rooster comb at the roughly 12 o'clock position. Makes it a lot easier to link up the manual valve. Alright, so for your control body complex, just want to double check, make sure your seals are in position. Okay, you have your speed sensor, harness assembly, everything is as it should be, and then of course you have your zip kit inserts. Alright, so very carefully lower the whole assembly onto the case, linking the manual valve with the corresponding stud on the rooster comb. Okay, there's going to be an alignment dowel over here, and then of course you have your seals in the center support. So just kind of gently but smartly press down on the whole assembly just to make sure that it is mated. Next, grab your starfish bolts. So these are snap-on 10 EPL. That's the socket that you will use to install them and torque them up. They get 71 inch-pounds of torque. And there's 6 of them and they're all the same length. So thread them in, you know, 4, 5, 6 threads, whatever. Alright, if the valve body is not fully seated, then after about 2 or 3 turns, they'll get tough, they won't want to go in. Okay, it's still not fully seated because you have seals, especially up here on the pump, between the pump and the valve body, that are kind of, you know, exerting repulsive force, if you will, against the assembly. So low power impact, again, only 71 inch-pounds. No particular tightening or torquing sequence. So I usually start with either this one or this one and then kind of work my way out. Okay, if you want, you can crank them down because they're going to take a little bit to get fully seated to where they're starting to tighten up because, like I said, you have the seals. Okay, now we'll go to torque. So check them. I must have missed that one, so that's why I always like to check. I have been guilty of missing bolts in the past, so I'm a little bit more cognizant of it these days. Alright, now we can install our detent roller. $10mm on that bolt. So this is going to get 106 inch-pounds. And then pan bolts will get 80 inch-pounds. So that's 80 inch-pounds on the pan bolts. Alright, once the control body complex is installed, go ahead and lube up your O-rings on your case connector. And then what you want to do is you have to align this slot here you see on the side of the connector here with the corresponding slot on the case connector in the Tecum. Alright, once it's in, just shut your latch and that's it. It's good. Alright, now your filter. So, a little bit of assembly lube. Make sure it's in, and then you're ready for the pan. So you always have a reusable gasket, and then here are your locating tabs. There's one here and one here, and then you have corresponding ports in the case for those tabs to go into. I wish all GM, Ford, and Dodge transmissions, at least the rear-wheel drive stuff that were ever made, featured both these kinds of gaskets and, you know, this kind of alignment configuration. Okay, your pan, make sure there is a magnet. Stick the magnet right here. If you stick the magnet, say here or here or somewhere else, it may interfere with the filter, and you will not be able to get the pan flush onto the pan rail of the case. Alright, 80 inch-pounds on all bolts. So all in all, this build went pretty well, pretty smooth. So we had a lot going on in terms of upgrades and mods and whatnot. But Circle D did a lot of the heavy lifting for us because they set up their clutch packs for the 3.5R, the 4.56, and, well, frankly, all of them, such that I did not have to use anything beyond the Circle D kit for purposes of achieving the desired or target clearance for any of the clutch packs. The Sonic zip kit components are fairly straightforward, so they don't include the entire zip kit. So as I mentioned in, I think, part 2 of this video series, you can augment what Circle D gives you with the rest of the zip kit if you want. Especially if your valve body has leakage at the bore plugs that are associated with the clutch select valves, clutch select valve 2 and 3, and or the compensator feed or torque converter regulator valve. These are all in the lower valve body. So that portion of the Sonic zip kit, all those little packets, they don't come with the Circle D kit. So it's up to you if you want to augment, but if you do your valve body testing and you find it's not sealing appropriately in those areas, then I would install the rest of the zip kit. Okay, both Sonics and Transgo make clutch select valve springs. In the case of Sonics, it comes in the zip kit. In the case of Transgo, it comes in their Tow and Pro kit, as well as a separate kit that you can buy just for the clutch select valves and springs. So both Sonics and Transgo give you a lot of flexibility in terms of how you want to augment your build and beef it up, or what corrective components you want to install. And that's great. I mean, you have a lot of options just with those two companies. And in Central Valve Bodies, they have drop-in valves for these transmissions as well. Alright, so you have the little bracket for a vacuum hose. Notice that the bolt for those is a little different than your pan bolts. So this has a washer and it's got a shallower hex head on it relative to pan bolts, so don't mix them up. The other thing is you want to be real careful here. You definitely want to use a torque wrench, because these bolts occasionally like to snap. And if you don't have a torque wrench and you're just going by feel, and your feel is not 100% spot on, like I know mine's not, you might snap one of these. Somebody on one of the forums that I frequent, he had that happen to him. Luckily, he was able to get it out, and there wasn't any drilling or tapping or anything he had to do. He was able to extract the broken piece of the bolt right out of the threads, and then just put a replacement bolt in it, and it was fine. If you live in a hot, dry, arid area, I don't know if that's as big as a concern versus somewhere else where there's just a ton of moisture. It's possible that the bolt was rusty and it was already eroding or kind of oxidizing, and it just broke off while he was trying to reinstall the pan. So he was using a torque wrench. He wasn't doing anything crazy. And that kind of thing just happens. So you just want to be careful. Don't get overzealous. Don't use 3/8 high power impacts to reinstall these. Well, common sense, to be honest. I mean, I'm just trying to fill the awkward silence with something. So as far as torque sequence on the pan, I've always favored doing, kind of the middle 2 or 3 and then working my way to the ends, but that ain't mandatory. I mean, you could do whatever you want. Main thing is you just want to hit every bolt. So it's another reason why I really like these kind of pan gaskets, and that is the steel bolt stops. I mean, you go right to torque and that's it. With traditional pan gaskets, they have to compress, so you really have to go around the entire pan 2 or 3 times. And this is true of all 3 and 4 speed transmissions when you're assembling them with the standard pan gasket. And that's kind of the composite style gasket. Whatever you do, do not ever use cork or a non-bonded style rubber gasket. And you will find those in the seal or gasket and filter kits that places like AutoZone and O'Reilly's and Advanced Auto Parts, those places that you know, that's what they will sell you over the counter, and those gaskets are worthless. They leak because they don't take torque evenly, and in the case of the rubber ones, they sometimes will pinch. In the case of the cork, well, it's just cork. It, you know, it leaks. So I mean, as you can see, I really only needed to go around once with this particular pan gasket, and that's how all of these go together, and same with the Fords. It's very, very easy. Alright, so extension housing, and then shift cable bracket, and we will be done with this thing. Alright, come with your housing and your seal. And just line up your bolt holes. .37 foot-pounds on these bolts. And I need a more powerful impact. So crisscross pattern, 37 foot-pounds. Yeah, there's a lot of, I guess, discussion and uncertainty around whether using extensions, especially wobble extensions, have any impact on the actual torque that's being passed to the bolt when you're using a torque wrench. I don't really have too much of an opinion on the matter because, just to be perfectly honest with you, I don't know you know, to what extent there is an impact. I mean, I can understand both sides of the argument. So I can't believe I'm losing that much torque to where suddenly these bolts are going to come loose at some point. I mean, I guess anything's possible, but I don't think it's likely. So I'll leave that up to you, the viewer. If you have an opinion, you want to weigh in, you can do so in the comments section. Be happy to hear from you on that particular issue. Okay. The very last thing we would need to do is install our, well, actually two things, our shift cable bracket and our you know, little, I guess, bracket for vacuum hosing or something like that. This thing. We also need to put in our small inspection cover. Get that in there. All right, I'm going to reposition the camera so I can get this thing to where it's upright, and then we'll go ahead and install those two things, and then I'll summarize the build. Okay, truly last but not least, we have our little dipstick port plug that we need to install. Okay. So that about does it for this build. All in all, it went pretty well. Circle D does a great job with their kits, putting them all together and giving you what you need. No major areas of opportunity that I've observed when using their stuff. I mean, you know, like I said, everything is pretty much as advertised. We didn't need to, you know, supplement any of their snap rings or, you know, swap them out for factory snap rings because the clearance was way out. I mean, you know, they pretty much have it down. So all new Tecum, it'll need to be programmed. If you're installing a Tecum bought new from General Motors or Sonics, you'll need to have that Tecum programmed using either AC Delco's technical delivery service with the you know, interface cable and the laptop, of course, or you can just have it towed to the dealership and then they'll program it for you. I think they charge somewhere in the neighborhood of $450 to $550, somewhere in it. It depends. And maybe outside those ranges you'll have to check with your local dealership, but you know, you'll have to do one of those two things. You can buy one of them from Street Smart Transmissions as well, one of those Tecums, and they will program it for you. Just give them your VIN number, and I think out the door it's something like $600, you know, with the programming and everything, ready to bolt on and run your fasted app Relearn. So, all right, that about does it for this build. Hopefully this video series was helpful for you if you're looking to build up a similar 6L type build profile and, you know, similar application and whatnot. If you're going to be putting out a lot more horsepower, something like, you know, 1,000, maybe 1,200 and beyond, you're going to want to augment everything you've seen here with an output planetary carrier with a billet drive plate, and you're probably going to want to run the 45 tooth you know, Power Glide spec clutch packs. You know, they do provide a little bit more surface area in that clutch than the 36 tooth, but again, here we're talking like 1,200 horse level 4 type stuff or stage 4. I've never built anything for that kind of power level. This is one of the most you know, powerful builds, if you will, in terms of just engine output that I've done. I had a couple others that are in this neighborhood, but, you know, nothing significantly beyond this. So anyway, thanks so much for watching, as always. Greatly appreciate it. If you have any questions, comments, get me below. If there's anything else you want me to cover as it relates to 6Ls, 6L 80 and 90 in particular, those are the two that I see most often. I haven't never actually seen a 6L 45 or 50, and they just don't come in the door. So anyways, enjoy the rest of your day or evening, and again, thank you so much for spending your quality time on my channel. I can't tell you how much I appreciate that, and all the support and views, engagement, and likes and commentary in the comments section. Take care, guys. Look forward to seeing you on the next one. Thanks again.